All right, today we're going to talk about solving systems of linear equations by substitution. But when we ask the question, is there an isolated variable? Sometimes the answer is going to be no. So with this first problem, we have 3x plus 7y equals 14 and x minus 5y equals 12. There is not an isolated variable. So we're going to have to choose an equation where the variable is easiest to isolate in one of the equations. So, for instance, in this problem here, notice how this second equation, x, has a coefficient of 1. So that means it'll be easy to solve for x. And that's what we're going to do here. So we have x minus 5y equals 12. We're going to solve for x by adding 5y to each side. After we add 5y to each side, notice how negative 5y and positive 5y cancel so that we're left with x on the left side of the equation, and then the right side is 5y plus 12. And now x is isolated. So now we come over to step 2 and substitute the expression for the isolated variable into the other equation. So notice that our other equation is 3x plus 7y equals 14. And where we see x, we're going to substitute 5y plus 12. And we get that from here. All right, so when we write this new equation, it'll be 3 times 5y plus 12 plus 7y equals 14. All we did was we wrote this equation, except for x, we substituted 5y plus 12. All right, it says solve for the remaining variable, which is y in this situation. So we're going to simplify and solve by distributing the 3 inside our parentheses. All right, so that we have 15y plus 36 plus 7y equals 14. Our like terms are 7y and 15y. They combine to give us 22y. And then we just drop this down, plus 36 equals 14. And now we subtract 36 from each side here, so that we're left with 22y equals negative 22. Final step is to divide by 22, and y is equal to negative 1. All right, y is equal to negative 1. All right, we have solved for the remaining variable, which was y. Now we're going to substitute that value right into this equation to solve for x. So that'll be x equals 5 times negative 1 plus 12. 5 times negative 1, negative 5, plus 12 is 7. So x is 7. So now we have a value for x and y. And we would write 7 comma -1 for our solution, but we need to check it. All right, we need to check this. So our original equations were 3x plus 7y equals 14. And we can just write this one here. X equals 5y plus 12. We're going to substitute 7 and -1. So this will be 3 times 7 plus 7 times -1. We're asking ourselves, is it equal to 14? 3 times 7 is 21. 21 minus 7. Yep, it's 14. These two are equal. And we got to check it in the second equation. So that'll be 7 equals 5 times -1 plus 12. Is this equal? 5 times -1 is -5. Plus 12. It is 7. So our solution is 7, -1. So notice that extra step. All right, in the second example, it says look at the equations. -4x plus y equals 1 and -3x plus 5y equals 5. Is there a variable isolated? The answer is no. So what we're going to do is take one of the equations, choose one of the equations to isolate the variable. And it's easiest to look at this first equation at y because the coefficient is 1. So we're going to isolate the y in this equation. So -4x plus y equals 1. We're going to isolate y by adding 4x to each side. So y equals 4x plus 1. All right, now that we've gone ahead and solved for y, we are now going to substitute that y into the other equation, which is -3x plus 5y equals 5. So for y, we have 4x plus 1. So -3x plus 5 and 4x plus 1. Now we're going to simplify and solve for the variable that's left, which is x. All right, so -3x plus 20x plus 5 equals 5. That's what happens when we distribute the 5. Our like terms here are -3x and 20x, which gives us positive 17x plus 5 equals 5. Subtract 5 from each side. We're left with 0 on the right side. So this is 17x equals 0. Divide each side by 17, and x is equal to 0. So we're going to substitute this value in step 3. We substitute the value we've come up with into this equation. So that means y is equal to 4 times 0 plus 1, and we get that y is equal to 1. So our point would be 0, 1. We got to check it though. So we're going to check it into -3x plus 5y equals 5. Then we're going to check it into y equals 4x plus 1. All right, so this is -3 times 0 plus 5 times 1 equals 5. All right, we know that this cancels, but 5 times 1 is 5, and 5 is equal to 5. So it checks there. The next one, 1 is equal to 4 times 0 plus 1. This cancels, and yes, 1 is equal to 1. So it checks in both equations, so our solution is 0, 1. All right, try